Hello class, today we are looking at writing algebraic proofs. So the essential question is, how do I write algebraic proofs? Learning intention. I'm learning to write algebraic proofs. You've got 3 warm-up questions. It says, identify the number of solutions for each of the following equations. Please pause the video now and see if you can do that. Well, I do hope that you tried to do it on your own. If you can get it done successfully, then you know that you've understood that concept. So let's start by distributing. So 3 times 2x is 6x. 3 times negative 4 is negative 12. That is equal to 6 times x is 6x. 6 times negative 2 is negative 12. What do you notice on both sides of our equation? They're exactly alike. So if they're exactly alike, does it matter what value I put in for x? No, because it's always going to be the same. This is your infinite number of solutions. Okay, for the next one, if you didn't try the first one on your own, pause again and try the second one. Well, I do hope you tried. We've got to start off with distributing. 5 times x is 5x. 5 times negative 4 is negative 20. And that is equal to 3x plus 10. Okay, now look at your coefficient of x. What do you notice? Over here, the coefficient of x was the same and the number was the same. Over here, the coefficient of x is not the same. If it's not the same, then that means you will have one solution. Subtract 3x from both sides. 2x minus 20 is equal to 10. Add 20 to both sides. Two x is equal to 30. Divide by 2. And x is equal to 15. This is one solution. Okay, let's look at the last one. Once again, you've got to start by distributing on both sides. 4 times x is 4x. 4 times positive 3 is positive 12. 2 times 2x is 4x. 2 times negative 7 is negative 14. What do you notice? The coefficient of x is the same on both sides. What about the numbers? The constants are not the same, which means when I try to move the x's to the same side, I'm going to subtract 4x on both sides. My x's are gone on both sides, and the statement I am left with is 12 is equal to negative 14. Does that ever, ever, ever happen? No. This is no solution, because 12 can never, ever be equal to negative 14. So we're going to look at algebraic proofs. How many of you did proofs in geometry? or before now? Well, all a proof is a step-by-step explanation of how you solve an equation, if it's algebraic. Your proofs are step-by-step. So you give a statement, you give a reason. Why can I say this? Well, there's lots of reasons you can do things, but they're not always a good reason to use. So as you're looking at this, we're going to start the step-by-step explanation of how to solve an equation. Now think of the arithmetic properties that we use. We've got the addition property of equality. We've got the subtraction property of the equality. Multiplication and division properties of equality. Then we can also substitute. We can simplify, or we can use the distributive property. So as we get ready to solve this problem, what are we going to do first? Well, I'm going to distribute. First thing I've got to do is distribute. So I get 30 is equal to negative 5 times 6 is negative 30, and negative 5 times 6 is negative 30. Okay, what's my next step to solving? Well, I've got to get the numbers to the same side. So I'm going to add 30 to both sides. This gives me 60 is equal to negative 30n. This is my addition, because I'm adding the same thing on both sides. Property of equality, PO, addition PO. Okay, last step, what do I need to do? Well, I need to divide both sides by negative 30. So this is my division. POE. And I'm left with negative 2 is equal to n. How did I get there? Well, I had to simplify from dividing. So as you're looking at this, this is nothing you haven't done before. But now we're putting a name to each step as we do it. So we're just doing a justification of why we solve the way we do. Okay, so when you're looking at proofs, 99% of the time you start with a given statement. 100% of the time, your last statement is what you want to prove. So you're going to be able to always put in the first statement and reason and the last statement before you even get started. So, as I'm looking at this, now, I don't know the reason for this last one yet, but when I get down there, I should. So let's start. What do we do first? Well, we know in order to solve this, first we have to do the distributive property. We've got those parentheses and we've got to multiply. So 4 times negative x is negative 4x. 4 times 4 is 16, so plus 16 is equal to 12. I've distributed. Now what? Well, I've got to get the 16 to the other side. So I've got negative 4x plus 16 minus 16 is equal to 12 minus 16. What have I done? Well, I've used subtraction. So this is subtraction property of equality. Now what? Well, I can't leave it like that. I've got to simplify. So I get negative 4x is equal to 12. Or negative 4, sorry. 12 minus 4 minus 16 is negative 4. And I've simply simplified what I've done. Okay, now what? Well, I've got to undo the multiplication. Negative 4x divided by negative 4 is equal to negative 4 divided by negative 4. This is the division property of equality. Now, how do I go from here to here? Well, how did I go from here to here? I simplified. Now, I need to tell my reader I am done. It is finished. I did such a good job. There's no way to argue with what I did because everything is mathematically correct. So to tell your reader you're done, I like to use the infinity symbol. You can also use QED. That's Latin for it is done. Okay. Can you give me the first statement and reason? If you said the given, you are 100% correct. Okay, start with your given. Now, I don't like working with fractions, so how can I get rid of the 1/5? What can I multiply 1/5 by and end up with 1? Well, you're thinking about reciprocals is what we're doing. The reciprocal of 1/5 is 5. I'm multiplying by 5. So what allows me to do this? The multiplication property of equality. Okay, now what does it look like? Well, it looks like A plus 10 is equal to negative 15. All I've done there is simplify. How do I get rid of the plus 10? Well, the opposite of addition is subtraction. A plus 10 minus 10 is equal to negative 15 minus 10. And what property is that? Well, that's the subtraction property of equality. So, A is equal to negative 25. I have ended with what I wanted to end with. Why can I say that? How do I go from here to here? Well, it's by simplification. and I am done. I'm going to let my reader know I am done. I like the infinity symbol the best, but that's what I do. Okay, so you know you're successful when you can write algebraic proofs. And this is simply writing algebraic proofs.